Okay, so here we have a problem that says a falling stone takes 0.28 seconds to travel past a window 2.2 meters tall. From what height above the top of the window did it fall? So here we have a diagram that depicts what is said in the situation given. So here's the window, and we're just gonna pretend that the stone, started from the roof of the building, and this was the path it made all the way to the ground, which it would eventually hit. So right here is the area of the numbers that we are given in this problem. We're not given information about up here or down here, just right here. So we know that when it passes this window of 2.2 meters, it takes 0.28 seconds for the stone to travel from the top of the window to the bottom of the window. So that is all we're given information about. So we know that the displacement, or the distance of this stone, would be 2.2 meters. The time it takes to travel that is 0.28 seconds. And the acceleration would be negative 9.8 meters per second squared. This is because this is a free fall problem. The stone is simply falling through the air, so there's no other force acting upon it other than gravity. So with that information, we need to plug it into one of our formulas to see what information we can find out next. So we have the acceleration formula right here, and we are not able to use that one right now because although we do have the acceleration and we do have the time, we do not have the final or initial velocity. So we can't figure out one variable because we don't have 3 out of 4 of them. We only have 2 out of 4. So that leaves us with the displacement formula. We are able to use this one because we do have the displacement, we have the time, and we have the acceleration. The only variable we are missing is the initial velocity. The only thing with this one is we have to reorder it so that we're able to use it to find the initial velocity and not the time. So the first thing you want to do, or the first thing I did, is subtract VI times t, because this is added, so you could just take this chunk and subtract it, and subtract x onto this side. So what you would end up with is negative VI times t equals 1/2 a times t squared minus x. So from there, what we can do is divide by t. We still have this negative sign here, so we will need to divide by negative. So what you can just do is just put a negative in front of this. You could have also divided by negative t if that worked out better, but it would be the same thing. So I'm just going to get rid of that. So again, we divided by negative right there to get rid of the negative on this side. So now we would plug in all our values. So initial velocity equals 1/2 times 9.8 meters per second squared times 0.28 seconds squared all over 0.28 seconds minus 2.2 meters over 0.28 seconds. So we have all our units present, and the units that we can cancel out are the seconds squared. Those we can get rid of, and what we are left with is meters over seconds on each side. So that would be meters per second, since it's division. And since we are subtracting these two, they will come out to equal meters per second, because we're not going to be multiplying or dividing them, so they will still come out to be meters per second. So after you do all the math, what you would have to do is 1/2 times 9.8, negative 9.8. times 0.28 divided by 0.28 squared. Just because you got rid of the s squared, you still have to square the seconds. So it would be 1/2 times negative 9.8 times 0.28 squared divided by 0.28 minus 2.2 divided by 0.28. So the answer you would get for the initial velocity is 9.229. And then there would be more decimal places after this, but this is far enough to go. Meters per second. So again, we found the initial velocity of this section right here. So what we found is the velocity of the stone at this point. So the velocity of the stone as it reaches the top of the window.